Oh yeah, welcome back to exponents. The type of exponents you should be comfortable for this practice are zero exponents, negative exponents, positive, rational exponents, adding exponents, subtracting exponents, multiplying them, all right? So I'm excited about this one because while it looks like a very simple task that it seems to be going nowhere, it's going to be a very powerful skill for our future practices. So take some time to pause. These are all in base 2, all right? So we want to be able to rewrite every single one of these expressions or terms with base 2. All right, so think of an exponent that will give you that. All right, so let's get started. If you need more time, then pause, but we will check now. So 8, how can we write 8 with a base 2? It's going to be 2 with an exponent of 3. So 2 to the third is 8. That's the idea if you didn't understand. All right, 1 over 4, because the reciprocal should be a negative. So 2 to the negative second. 16 is 2 to the fourth. All right. Let's see if you got a negative exponent here. And it is negative 3. What's the exponent for a 1? It's got to be a 0. What's the exponent for a 2? It's just 1, to get itself, it's just the 1. What's the exponent for a square root? It is 1/2. So 2 to the 1/2 here. 2 to the 1/2 power. Notice how they all have common base 2. That's the main idea. And this one is the reciprocal, so 2 to the negative 1. All right. Now those are the most common ones you will see. And then let's see something a little more advanced than that. Well, this one's also you will see very often, 2 to the 5th. And this one as well, actually. 2 to the negative 4. All right, so notice how we knew 2 to the 4th was 16. Therefore, 1 over 16 is 2 to the negative 4th power. Less common, but we will see them are these radical expressions. When there's a radical, we have an exponent that's a fraction, otherwise known as a rational exponent. And the question is it 4 over 3 or is it 3 over 4? The root isn't on the denominator, right? So think of it as 3 over 4, 2 to the 3/4 power. And then this one looks just like this radical 2, but it's the reciprocal. So therefore we have 2 to the negative 1/2. Great. For this one, we might want to do think what's happening with what's the operation happening with the same base as multiplication. Therefore, what can we do with those exponents? We're going to add them. This is 2 to the 13th. What's happening between these two bases? We have division, a quotient. And in this case, because it's x, we can't really simplify that. So we're going to represent it as 2 to the, is it 3 minus x or x minus 3? This is the second one, is x minus 3, all right? You can write it in parentheses if you prefer, but that's the idea. And then here you have to do a little bit more thinking. If you got this one on your own, then you're in the right track. We can rewrite this as 2 times, I mean, it is 2 times radical 2, but we can write it as 2 to the first times 2 to the what power? It is 1/2. Therefore, because those are the same base and multiplication, we can add their exponents. 1 is the same as 2 halves, so 2 over 2 plus 1/2 is 3/2. And there it is. So those are all different types of expressions that can all be rewritten with base 2. That's kind of cool, right? How different they look from each other, but they're still saying all base 2, no matter of how different they look from each other. All right, great. So let's see, just so we can get some more practice with a different base. But if you got this idea and you want to try it on apply it in the next video, you're more than welcome. Do that right now. If you would like more practice, here's some more expressions with base 3. See if you can apply this with base 3. We're going to check them right now. So if you needed more time, you can still pause it, but we're checking it at this point. What is the exponent for 81? Remember, all these are base 3. The exponent is 4. So again, that's one of the very commonly seen type of expressions. The radical is another one that shows up a lot, especially when it's just square root. That one is 3 to the 1/2. So that one is one you should be emphasizing. This one is 3 squared. What's the exponent for this one? It's 3, but now it's to the negative 1/2 instead of to the 1/2 power. And this next expression is 3 to the negative second. All right, what's happening here? we have an exponent raised to another exponent, or power to power. In that case, what do we do with those exponents? We're going to multiply them. So 5 times 7 is 35. If you're confused about that, check out the video for multiplying exponents. And then here we have to do a little bit of rewriting, I believe, before, unless you can do it in your head already. It's not that hard, but it is doable. But let's rewrite this as, we're going to say 3 to the 1/2 for the numerator. Right, we said that here, radical 3 is the same as 3 to the 1/2, so this is 3 to the 1/2, and this is just 3 to the 1st. And therefore we can, I say, all right, what do we do with the exponent? We're going to say 1/2 minus 1. So be careful with this one. This is, maybe I should write it here on the left side since I'm running out of space. On the right, this is the same as 3 to the 1/2 minus 2 over 2 is negative 1/2, so be very careful. And it turns out that this is the same as one of the expressions we've seen before. Look, 3 to the negative 1/2 is right here. It's the same as this. So it means that this expression right here, this one is the same as this one right here, apparently. Check that out. That's pretty cool, huh? All right, so I hope that you got those exponents correct. If that's the case, oh, you're on fire. And if you would like some more practice, even if you're on fire, we can get some more practice with base 5. And again, this is just, it's not a different idea. It's just to get you used to seeing these other numbers with base 5 and with base 3 and base 4 and so on. All right. You will see those often, promise. So here we have multiplication, same base. Therefore, what can we do with the exponent? We can add the exponents, but because there's a variable involved, we can only represent it as x plus 4. If you prefer the use of parentheses, then that's fine. Otherwise, make it very, very clear that the plus 4 is part of the exponent the way I have. Look at all this space underneath it. So that's the main idea. All right, what's happening with these exponents? We can multiply them. Or another alternative, oh no, but here we're specific. We want to be specific with base 5. So therefore, the only thing left to do is multiply the exponents. Therefore, this expression becomes 5 to the 3x. That's it. We can't go simplify that further. We have division, same base. Order matters here. Should it be 6 minus x or x minus 6? It's the exponent for the numerator first, so 6 minus x. And there it is. This one on the right, 125 is base 3, so 5 to the 3rd power. This one is 5 to the negative 2nd power, reciprocal of 5 squared. And this one's reciprocal of 5 to the 1/2, therefore 5 to the negative 1/2. Cool. I believe that's it. Yep. So I look forward to applying this idea in the next video, and it's going to be very powerful for many future videos involving exponents. Awesome. So I hope that you have a great rest of your day and enjoy your time practicing math today. I don't know why you're still listening to me when you should probably click on the next video or go do something else. All right, but either way, goodbye.